All right, this is AP Calculus AB. Looking at homework for trig inverses. Number one, we got the derivative of sine inverse of 5x. In this case, we are saying that u is equal to 5x. And the formula for this is u prime, the derivative of 5x is 5, over the square root of the difference of 1 and u squared. U squared would be 25x squared. Number two, we got the derivative of cosecant inverse. Cosecant inverse is a negative. We got u squared up top, pardon me, we got u prime up top, the derivative of this, which would be 20x to the fourth, and that's over the absolute value of u. U is 4x to the fifth. And then we have the square root of u squared. If you square, tell you what, let me write this down. If you square that, you're going to get 16x to the 10th. So that would be 16x to the 10th minus 1. Number three, we got tangent inverse. Tangent inverse, we need to know what u is, which is 2x, u prime, which is 2, u squared, which is 4x squared. Well, tangent inverse's derivative is equal to u prime, which is b2, over u squared, which is 4x squared, plus 1. Dunsies. Number four, wow, this is horrifying. This is the quotient property. It says nothing to do with inverses. So you take the derivative of the top, the derivative of sine is cosine, times the bottom, minus the top times the derivative of the bottom over the bottom squared. And I would probably rewrite this as x cosine of x minus sine of x over x squared. 5 is an inverse one again. Secant inverse's derivative. So I'm going to say u is the angle, u prime is 3x squared, and u squared, which is u squared, would be x to the sixth. Secant inverse's derivative is u prime, which is 3x squared, over the absolute value of u, which is x cubed, times the square root of the difference of u squared, which is x to the sixth, and 1. Number 6, this angle is 6x, really should be in parentheses. The derivative of cosecant of 6x, well, the derivative of cosecant, which is the outside function, is cosecant of the angle is negative cosecant of the angle times cotangent of the angle. So that would be negative cosecant of 6x times cotangent of 6x. This is the chain rule, because then you got to multiply it by the derivative of the inside function. The inside is 6x, its derivative is 6. So we could write this as negative 6 times cosecant of 6x times cotangent of 6x. Number 7 is a limit. Well, let's see. If we were to put 2 into the top, we would get 0. If we put 2 into the bottom, we would get 4 plus 10 minus 14. We would get 0 on the top and the bottom. So since that's 0 over 0, we can use L'Hopital and make this the limit as x approaches 2. Take the derivative of the top, which would be 1. Derivative of the bottom is 2x plus 5. And then if we use substitution, we're going to get 1/9. L'Hopital rules. L'Hopital's rules. Number 8, the derivative of an inverse function, cosine, u is 3x squared, u prime is 6x, and u squared is going to be 9x to the fourth. Cosine inverse's derivative is negative u prime, which is 6x, over the square root of the difference of 1 in u squared, which is 9x to the fourth. Number 9, the antiderivative of this monster. Well, this takes us to our integration rules for this. And our integration formulas, which I have misplaced. There we go. Since this is a square root and it's 1 minus something, this is either sine or cosine inverse. And since it's positive, it's sine inverse. So for this to match up with sine perfectly, here's what sine looks like. It's integrating u prime over the square root of the difference of 1 and u squared du. So in this case, what are we saying that u squared is? U squared is 25x squared. That's going to make u 5x, and that's going to make u prime 5. And look, all that checks out. 5 is where u prime is. 25x squared is where u squared is. So this is going to be, as suspected, sine inverse of u. And what is u? It's 25x squared. Throw in your arbitrary. I'm sorry, u is not 25x squared. U is 5x. Sine inverse of 5x plus your arbitrary constant. 1,000 pardons. Looking at number 1 here, compute the derivative of this monstrosity. This shouldn't be too hard. It's just applying thousands of rules that we learned in the past. The derivative of natural log of x is 1 over x. The derivative of sine of x is cosine of x. The derivative of arctangent, just a reminder that arctangent of x is equivalent to saying tangent inverse of x. Should have mentioned that in the notes, and I didn't think of it, quite frankly. The derivative of arctangent is the derivative of the angle, which would be 1, over the angle squared plus 1. That's one of the new rules that we just learned. And then if we add to this, how do you take the derivative of 2x? Well, you take the derivative of the exponent, which would be 1, times the original function, and then you multiply it by natural log of the base. Now this part here we don't see a lot because usually our base is e and natural log of e is 1, but that is how she's done. Let's see if this matches up with any of these. These all have 1 over x at the beginning, minus cosine, plus, so that last part didn't work for this one. Looks like we're going with D here. Picklesworth. Got 1 over x minus cosine, 1 over 1 plus x squared. We wrote as x squared plus 1, and then natural log of 2 times 2x. So that is definitely D. Let's check out number 2. What is an equation for the line tangent to this at this? Well, to do this, we need a point of tangency. To find this point of tangency, we're going to take the y equals tangent inverse and replace the x with the square root of 3. So our point of tangency is square root of 3 and tangent inverse of the square root of 3. To find the slope of tangency, we're going to take this derivative, y prime. Tangent inverse's derivative is u prime, so that'd be x prime, which is 1, over u squared, that's x squared, which is x squared plus 1. If you put the square root of 3 in for this, we're going to get u prime is 1 over the square root of 3 squared plus 1, which is 1 over 3 plus 1, which is 1/4. So our slope is 1/4. If I look at my answers, I don't see tangent in any of the answers. So what that means is I need to figure out what tangent inverse of square root of 3 is. If I were to, in quadrant 1, remember that tangent is y over x. So if y is square root of 3 and x is 1, that's a special right triangle, 30, 60, 90, which makes this 30 and makes this 60 in radians. That's pi over 3. So we're saying y here is pi over 3. So I want an equation that's y minus pi over 3 equals the slope of 1/4 and then x times the square root of 3. And that is looking like, that is option E. Sweet. On the flip side here, page 2, if you will, got some integration to do. These are separate terms, just integrate them separately. Integrating cosine of x is sine of x. Integrating sine of x is negative cosine of x. A negative times a negative is a positive, plus your arbitrary constant. Number 2, well, I would certainly multiply this out, so it's secant squared of x plus secant of x tangent of x. The antiderivative of secant squared is tangent of x, and the antiderivative of secant of x tangent of x is secant of x. Oops, plus c. I would review those rules. Number 3, it's a definite integral. So the antiderivative of 2 cosine of x would be 2 sine of x. Got to evaluate it from pi over 4 to pi. That's going to be 2 times sine of pi minus sine of pi over 4. Change these outer ones to brackets. Sine of pi is 0. Sine of pi over 4 is square root of 2 over 2. So this is 2 times negative square root of 2 over 2, which is negative square root of 2. Let me just refresh your memory how I know what sine of pi is and sine of pi over 4. Pi over 4 is in quadrant 1, 45, 45, 90, which, depending on how you want to do this, we could say the legs are 1 and the hypotenuse is 2. So then sine is 1 over the square root of 2, y over r, which rationalizes to square root of 2 over 2. Pi is over here, this location, the y value is 0 and the r value is 1. 0 over 0 is 0. That's why I chose 0 for that. Alrighty, number 7. This looks quite intimidating. This is one of the new inverse integration rules that we just learned. So let's see. This appears as though it doesn't match up to anything. And maybe something's been simplified. Let's set u squared equal to 36x to the sixth. That would make u 6x cubed, would make u prime 18x squared. Now if you look here, that's not an 18x squared. This is not a 6x cubed. But could they have been those things? If we multiply this top and the bottom by 6x squared, would that change things a bit? It sure would, because that would make this the integral of 18x squared. If we just put this in here into the square root, we would have the square root of 6x cubed, and then the square root of 36x sixth minus 1. So now it matches up perfectly. This is u squared, this is u, I'm sorry, this is u prime, not squared. This is u and this is u squared. The trig function that this matches is secant inverse. Our u in this case is 6x cubed plus your arbitrary constant. I don't think that the AP test is going to be plastered with these types of problems. Could be one or two, and we'd like to be prepared when those one or two happen. We got quite a bit more. Number 8. This is a negative, so it's going to be one of the cos. I think this is going to be cotangent. Let's see. If we set u squared equal to 4x squared, that would make u 2x. That would make u prime 2. That matches up. This is u squared, and this is u prime. So this is cotangent inverse, and our u is 2x plus the arbitrary constant. Number 9 is the derivative. This is an old one. Take the derivative of the outside, which is cosine. Inside stays the same. Chain rule times the derivative of the inside. So that's going to be 5 cosine of the angle 5x. Number 10, it's a double chain. This might be better written as the derivative of secant of 2x squared. This means the same thing, but it gives a clear definition of what's on the outside. The clear of the outside is the 2. Inside stays the same. Subtract 1 from the exponent, so it's to the first. Then we take the derivative of this. Derivative of secant is secant of the angle, tangent of the angle. Then we have to multiply it by the derivative of the complete inside, which would be times 2. So the 2 and the 2 multiplied are 4. And if you look, we have a secant of 2x and a secant of 2x. So that's a secant squared of 2x. And then we have a tangent of 2x. Let's kind of make this smaller to get it out of the way. Number 11, integrating secant squared of x, so that's tangent of x. Integrating x is 1/2 x squared. Throw in your arbitrary constant. Let's see, this next one, can't do it directly. Maybe if we manipulate it a bit, we can do it. So for example, I could change this to sine of x. Let me rephrase that. I could change this to sine of x over cosine of x times 1 over cosine of x. Sine of x over cosine of x is tangent of x, and cosine of x is secant of x. Do we know what the antiderivative of this is? We sure do. It is secant of x plus your arbitrary constant. 4 more. 15, when I see these radicals in here, I'm thinking it's probably an inverse trig function. So when I see 1 minus inside a radical, I think sine or cosecant. It's positive, so I'm thinking this is probably going to be sine inverse. U squared, we're subtracting from 1, so that would be 16x to the 10th. That would make u 4x to the 5th. That would make u prime 20x to the 4th. Look, it all matches up. This is u prime, this is u squared. So this is sine inverse. Our angle is u, which is 4x to the 5th, plus your arbitrary constant. Yahtzee. Good thing I gave you lots of room for that one. 16. Let's see. Can't do it in its current form. I'm going to rewrite this as cosine cubed of x over cosine squared of x plus 4 over cosine squared of x. Cosine cubed divided by cosine squared is cosine of x. And I can write this as 4 secant squared of x. Now we can integrate each of these. The antiderivative of cosine is sine of x. Bring down the coefficient. Antiderivative of secant squared is tangent of x, plus your arbitrary constant. Number 17, we could write this as x minus 2 times secant squared of x. We would do that because I know how to integrate secant squared. So x is just the power rule of integration, 1/2 x squared minus 2 tangent of x dx. Derivative of tangent secant squared, so the integration of secant squared is tangent. Last one, number 18. Okay, so this 1 plus on the bottom with no radical, no absolute value, tells me this is tangent or cotangent. It's positive, so it's tangent. To proceed, whatever you're adding to 1 is u squared, which makes u 9x to the 4th, which makes u prime 36x cubed. It's a problem. Don't believe this matches up as it should. So if I double, I can fix this. I can't fix this. If this 7 was a cubed, I could get this to work. Well, I'm going to stop there. I don't think 18 works. I think it's a bad problem. If it's not, my apologies. If it is, I'll end up fixing it later. Peace in the Middle East.